Hello friends, my name is Matt and welcome to the Joy of Nerding. Today we're going to be doing a few computer stories, what I was up to this weekend, playing around with AI, and also helping a friend recover some data from ancient and venerable laptops. So for starters, in the reverse order of what I said, my friend Suda is moving, and when one moves, one cleans out one's house. And she found a couple of laptops that she'd stuck in a corner when she got her new MacBook, right? This is 2 generations of laptops. So there's the college laptop and then the laptop she had when she was out of college. And then later she bought a Mac of some variety laptop, MacBook Pro, probably. And she'd kept them because she always meant to pull the data off of them. And there's no time like the present. And why lug them on yet another house move, right? So she brought them over, essentially said, I could have them if I helped her get the data off of them. And one of them I'm fairly certain is not really useful except as a retro gaming thing. The other one I think would make a good type up my papers and practice typing and so forth type laptop for the kids at this point. And of course, regardless of keeping the laptop, I'd help her get her data off anyway. And for the laptops that are not worth keeping, I'll just bring them to e-waste recycling because it's free in my town. And so, again, strip them for parts, pull the drives out, wipe the drives. If the drives don't work, put them in the pile of drives to be destroyed via kinetic means. Drill press, press, high-velocity ammunition, low-velocity ammunition, looking at 223 versus 300 blackout on hard drive platters is very interesting because 223 is smaller and high velocity, so it tends to punch nice, neat holes in it, whereas 300 blackout is bigger and slower and tends to just shatter it. It would be interesting to do 300 blackout versus 30-06 with the same bullet and see what that does. But again, I digress, and I'm maybe the only person interested in such kinetic damage effects. Anyway, so I had my trusty SATA drive adapter. So the SATA drives go in here and it can take a big SATA drive or a little SATA drive, and you plug it in and you turn on the button and it's USB on the other side, right? So that works really well. You plug this in, works great. And then she shows up with this monstrosity, which is a Dell Inspiron something or other with a Windows XP Home Edition on the bottom. Oh joy, that's going to be fun. So this is where I start to realize this is probably not really all that useful. And also she doesn't have the power adapter for it, which is the real kicker. She could boot it up and probably get stuff off of it because Windows XP Home supported USB. She could plug in a USB drive, but she doesn't have the power adapter for it. So I'm pretty sure this is going to end up in the junk pile. The RAM is too slow to be used in a modern laptop. The hard drive is accessible because this is how they used to do things back in the day. You can pull out just the 2 screws here. And to an extent, some laptops are still made this way. Here, let me get the other screw out. And then you pull the hard drive out. To an extent, everything is accessible. This is the battery. You can get at this without tools. This is the RAM. 2 screws, pop it open, and you can pull out or add new RAM, right? Novel concept. My ThinkPad is more or less like that. It's got RAM on both sides, so you have to pull the keyboard off in order to get at the RAM that's on the top. But the RAM that's on the bottom, you can just undo the bottom cover and get at that. There's 2 hard drive slots, and one of them is actually 2 NVMEs. So it can actually take 3 drives, which is really nice. So anyway, I pull out the hard drive, and it looks like this. Now, this is not the actual hard drive. This is an adapter piece that comes off, which reveals this. Not SATA, right? This is old parallel ATA, and this is the mini parallel ATA that you would get in laptops, 2.5-inch drives. When they developed the SATA form factor, they kept it to this width, so you can use the same connectors as power and data next to each other for desktops and laptops. So apart from the fact that a big hard drive wouldn't physically fit into a laptop, you could do that. But this drive does not fit in this, right? It's not gonna, I mean, physically it fits, but it doesn't mate up with the connector because it's very different. But wait, I said, I have one of those. And so I proceed to go into my big bin of stuff and cables start flying. It's every much as dramatic as your mental image. So I go in and I find this, which is my universal hard drive adapter. On this face, which is it? This one, it has power and USB. And there's associated power adapter brick and USB cable, which is exactly what you'd expect. And then on this face, you have SATA, which is what you would commonly use today. And that's what that other adapter dock has. That other adapter dock is just more convenient to drop in a hard drive that you want to mess with. And then you've got this side, which is big parallel ATA for desktop hard drives from a woebegone age. And then this is laptop size parallel ATA. And if you look, there's a little blocked out pin there. And this one does not have one, but it has a notchy thing here. And so that notch physically stops you from plugging it in the wrong way. And this plug physically stops you from plugging it in the wrong way. So you mate this up like this, plug it in like so, plug it into USB and power, turn on the power, plug it into your laptop. I find that this worked best when you turned on the power first, let it boot up, and the internal microcontroller here reads the hard drive and finds out what it is. Then you plug it into your laptop. And then you plug it into USB on your regular computer, and it sees the drive as what it is, and you can mount that. And we copied off the 15 gigs of data that she cared about. I don't even know how big this is. 5,400 RPM, 60 gigs. Yeah. So this is a 60 gig drive, which I've got larger spinny drives sitting in a pile that I might use someday. This is not going to get used. I'm just going to hook that up to the USB adapter that I showed you, run a 4-pass overwrite wipe with various bit patterns, and then I'll just probably recycle the whole thing. I don't know that that would be useful to really run anything. I mean, maybe you could put like FreeDOS on it, and it would be interesting in that sort of regard. But I'm not really sure, and I don't really want to put any money into it. If I had a power adapter, I'd probably keep it, but it doesn't, so I won't. The other laptop was a little more interesting. She has the power adapter for it, and she could boot it up, but when she tried to plug in her external hard drive, it wouldn't work. Now, she'd reformatted her external hard drive to work with her Mac, which I think was like HFS Plus is the standard Mac file system these days. I could be wrong. And when she plugged it into that other machine, which was Windows 8, it had no idea what to do with it because Windows 8 doesn't really understand Mac file systems, period, especially not modern Mac file systems. She was sort of out of options, and I just said, bring it all over. And I gave her one of my external spare SSDs that didn't have anything on it. It's used for data transport tasks like this. So we plugged it into that Windows machine and reformatted it to something that Windows machine can understand. And then I verified that I could copy a little bit of data onto it. And she didn't have her Mac with her, so we couldn't verify that the Mac could understand it. But I did a quick Google, and I had formatted it as an exFAT drive. And OS X has been able to read exFAT drives for something like a decade at this point. So even if her laptop's a little old or not currently up to date, it shouldn't be a big deal. And so she's going to bring my drive and that laptop back by at some point in the future. And hopefully now she'll be able to get all of her data out. Should actually check in with her and see how she's making out with that. But realistically, that one is a little interesting. It was some 64-bit CPU. I checked that off of the system information, but I forget which one it was. And it had a 4 gig SODIMM in it, and it had a spare slot, and I think it had some soldered to the board. I also think that I have some SODIMMs that will fit that and be speed compatible in the Boneyard, which means that it's some 64-bit Intel Core i something from a decade ago with some amount of RAM that I'll probably be able to push up to 16 gigs. And one of the interesting eccentricities of it is it had one of the M.2 2230 slots and a standard SATA drive. I tried to just pull the drive out and plug it in with the SATA adapter, and my system could read it, but it said that the file system was incomplete and possibly corrupt. Yet when we booted it up, it seemed to work fine. And I had this vague memory of this real small time slice where for a period of maybe 5 years, which was in this interim time where SSDs were new, but they were really small and expensive. And it was before you could just get big SATA SSDs cheap. What they ended up doing was they put in an NVMe slot, and they'd put in a really small drive. And then they'd have a spinny hard drive kicker, which was your bulk storage drive, say 500 gigs. And the NVMe drive would be 4 gigs. And you put the OS and swap file on that one, and then you would have the bulk storage on your spinning drive. And further, I want to say that there were a series of hard drives called SSHDs, where they integrated a small SSD and a big hard drive into one package, and it would quickly write to the SSD portion of it, then it would slowly flush that out to the hard drive portion of it via some management fanciness. And again, that's basically all gone away because you just buy a straight SSD these days. So I think there was a time where you could fake an SSHD in the BIOS of the system. And I want to say that that's what was happening with that laptop, which is why when I tried to mount just the one drive, it was incomplete because a bunch of the other stuff was stored on the SSD. Now, apart from this being a historical curiosity, there's no real value here. I'm going to rip out the SATA hard drive because it's slow. I'm going to rip out the M.2 2230 NVMe drive because it's small. And then I'm going to spend $50 and throw in a 0.5 terabyte M.2 NVMe, put Linux on it, and we should be good to go. And my kids can share the laptop and use it for writing papers and things like that. I mean, heck, playing Minecraft is probably fine on it too. And realistically, if you think about it, it keeps stuff out of the landfill. Now, the one bit that's a little iffy on it is when I was trying to format that drive, I was finding that the keyboard was not particularly responsive. And I'm wondering if there's an issue with the keyboard, but it also could be that just Windows is pokey and slow and hadn't been booted forever. So it was trying to do all of this system maintenance stuff and was just failing hard at it. And so it was not knowing that it was missing keystrokes. And when I would shift hold something, it also could be that when I ripped the hard drive out, I knocked a cable. So since I'm going to be all up in there anyway, I'm going to pull some stuff out and check all of the connections and reset the BIOS so that it just uses the M.2 drive as a standard M.2 drive, and then I'll boot from a USB stick and just do a basic system test on it and make sure everything works before I spend any money. It may be something as simple as I'm going to check all the connections, install the extra RAM that I find from the back, pull out the drives that I don't need, and boot it, and then run memtest86 on it or something like that. And one of the things I'll do as a keyboard test is make sure that the keyboard works. Because if the keyboard doesn't work, I don't know if it's as useful. Realistically, you could always just hook up an external keyboard and I could have my kids use it like that, right? You could hook up external keyboard and monitor and just use it as a luggable that you connect to your TV like you did back in the day. Not really sure, but I like to try and keep things out of the e-waste recycle stream as much as possible, which this is actually a really good time to do that because a lot of people are getting rid of their Windows 10 machines that won't run Windows 11. But guess what? They'll run Linux just fine, and they could be between 5 and 10 years old and still be great. All right, friends, we're going to pause that for just a second by way of an epilogue. It turns out I did not have RAM that fit in that laptop. The RAM that I had was DDR4. That laptop needed DDR3. However, it turns out that DDR3 RAM is so completely dirt cheap at this point that I could get him 16 gigs for $20, including delivery. And so I pulled out the 4 that was in there. There was not any additional soldered on the board. It was just that 4 of DDR3 something or other. So I got that installed and tested out. Test just fine. And I also had a spare 0.5 terabyte Western Digital SSD that we replaced the Spinny with. Also, it turns out that that hybrid drive setup is actually some Windows version of Metadisk. When I dug into it a little bit, it was almost like a RAID 0 concatenation. I assume that it was smarter than that, but that was what the technology appeared to be based on the partition and file system signatures. So I erased that. I don't know why it was only using 4 gigs. Turns out that's a 32 gig drive. So I repartitioned the whole thing, made it Linux swap actually. So he's got 32 gigs of high-speed swap for his 16 gigs of RAM. Now you may be wondering, why not just stick an M.2 drive in there and have the whole thing be fast? Because it's not M.2. It's some other form factor. It's keyed differently and the dimensions are different. So it's some Intel flash bus standard that never really caught on. It is what it is. He's got that. He's got the storage, and that's the hard drive is where the root file system and all that lives. So then I tested the RAM. I know the drive's good because it was from my working polls pile. It was pulled out of service. I knew that it worked. It just sat there for a while. And so that's good. I installed Ubuntu on it, so that should work just fine. And then, of course, the first thing he asked is, can we install Minecraft on it? So I grabbed Prism Launcher for him. We installed Minecraft. It worked. We had to tweak the settings a little bit because that laptop has 13-year-old Intel Iris HD graphics. I mean, it'll work. You just got to turn the settings back a little bit. So we did that, and that's all good. And so he's playing Minecraft, and he's happy. Of course, once you have Minecraft installed, right, he wants to install mods, and given Max being Max, he has FNAF on the brain, and he wants to install the Five Nights at Freddy's mods, so he could do all the Five Nights at Freddy's cool stuff. Okay, great. So we go to install that, and that's wonderful, and it installs just fine, but it is really slow. Apparently, it's a big old total conversion that requires much more graphics horsepower than vanilla Minecraft Java Edition, and so he gets himself into a functional state, but we had to really turn everything down, and it's still a little laggy. So he has a functional laptop. He can type papers on it, but he's going to have to get into building himself his own computer, I think, at this point, which is where his brother is, right? His brother wants to play games with my brother and my nephew online, right? 4 of us. Right now, the short list is Homefront the Revolution, so we can all shoot communists together. Not for the channel. They would very much enjoy doing that, and I think Max is not in that same vein, but he's more interested in the building games than the shooting games. So they're going to end up very much getting bitten, I think, by the computer hardware bug and have to start building things themselves, and that's fine. We'll go down that road. It's a lot of fun. And so that is the epilogue for the laptop. He has a functional laptop. It's perfectly good. Thanks to Suda for making that happen, and we saved another thing from the e-waste, which always makes me happy. So that's kind of story number 1. Story number 2 is how I spent my weekend. So to talk a little bit about the workflow for the channel, I record stuff using microphones and cameras and things like that, and record it in OBS Studio. There's a probability that I might stream, but honestly, I just like the camera control of OBS Studio. I find that it has everything nicely in one place, so that's good for me. And then I go through and I edit the video together in Kden Live, and I don't really worry much about the audio. at that point. I cut out the audio and video clips so that the audio is time correct and syncs up with the video and all of that. But I don't worry too much about cleaning up the audio at that point. I listen to it, and if it's something's really bad and I don't think I'm going to be able to save it, I just leave it on the cutting room floor. And I also don't worry about mixing it. I export all the audio tracks as FLAC, then pull them into Audacity and use Audacity's much better toolkit for leveling and doing LUFS, loudness, uniform, full scale normalization, and also the track volumes relative to each other. So my audio is targeted at -14 LUFS that I'll then go through and listen to and tweak a little bit if I think I'm a little too hot or a little too cold. And also I'll level the video game audio or whatever, if there is any, appropriately. Also, when I have the vocals track done, I run that through a subtitler that I had been using, a software called Auto Subtitle, which uses Facebook Meta's Whisper model. And the biggest problem with that is it was slow. It was reasonably accurate, but it was slow. And I mean, less than real time. Benchmarking an 8-minute and 48-second video, it took 11 minutes and 40 seconds to do that. And that's maxing out all the cores on my Ryzen 3700X. So I started looking for something that I could use that would be faster, better. And I found this project called WhisperX, where he had worked on splitting the audio and then batching it for more parallelism. He employed a bunch of tricks and then time normalizes it at the end. It's easy enough to install, so you just use pip, etc. And I'll link to my installation instructions in the show notes. So to be clear, this is the same 8-minute and 48-second video, and it's using the large V3 model for Whisper. That got the time down to 5 minutes and 25 seconds. That's wall clock time. And again, same machine as well, right? So then I was digging around and it was still running on the CPU. Well, I never bothered to check what AI model runner Auto Subtitle was using, but WhisperX uses C-Translate 2. And there's a guy, Arlo Phoenix, who forked one version of C-Translate 2 and got it to work with the ROCm library from AMD. And so I grabbed that and I followed his instructions, which was using ROCm 6.2.0, which I installed on my system. It was a little tricky because it's like 30 gigs and I was trying to I wanted to just grab the packages, right? Keep it easy. The problem is that it pulls in 35 gigs worth of packages and my root file system was only 50 gigs because how much do you really install on root, right? Home is separate, var is separate, temp is separate, but this kind of blew that out. So I ended up needing to go back, boot it into single user mode, resize the file systems down. I RAID all of the things. Okay, I'll include a link to my layout in the show notes. I tend to do RAID mirrors for most purposes because otherwise you need even more drives. So you have two drives and their partitioning scheme is identical. You have one mirror that is just a straight metadisk mirror and it contains a file system that the bootloader can mount. So it's like a metadisk that just has ext4 on it. That's where the kernel lives. So Grub knows how to open a metadisk, knows how to open a file system, knows how to boot the kernel. The kernel then opens the other metadisk, which contains an LVM physical volume, which the kernel knows how to mount. And then the kernel reconciles that physical volume into the associated logical volumes. And those logical volumes have file systems. And now you're off to the races and can mount everything. The nice thing about that is you don't have to mess around with physical partition boundaries. At that point, things need to be adjacent. So if you ever need to resize, you have problems doing that. Whereas if you're using LVM, it can just steal the bits from wherever they were. They don't have to be physically contiguous like they do when you're doing physical or logical partitions on the hard drive, right? So I resize down the home ext4 partition. Then I resize down the logical volume by the same amount. Then I increase the root logical volume by that 150 gigs. Then I resized the root file system, expanding it by those 150 gigs. So now I have a 200 gig root file system on the main drive array. So at that point, I can then install the RockM dependencies, woohoo, and then I can rebuild ctranslate2 against those RockM dependencies and install that into the Python venv. Also, I think I needed to install PyTorch, which was compiled to use RockM. So again, the Arlo Phoenix's instructions were pretty clear, and that got me down to 44.5 seconds. So 8-minute, 48-second video subtitled in 44.5 seconds. Now, that was a video clip. Most of my videos are longer than that. I shoot for about half an hour, hour and a half, 2-hour lengths because I grew up in an age of TV and I'm used to those delimiters, right? So, and I mean, plus or minus some amount, there's some variation there. I work at it until it's done. And then I leave the stuff I don't like on the floor. Point being, I threw that now GPU accelerated model at the one that I'm currently working on, which is 1 hour and 57 minutes. And it did that in 4.5 minutes. Now the baseline for comparison was over 2 hours. So on CPU, it's doing it over 2 hours. And at that point, I need to arrange my day so that I need to get this done. And once the editing's done, I can throw it into subtitling, and then I'll go do something else for 2 hours because I can't work on the subtitles or even the audio editing while that's happening because it's pegging the CPUs, and that makes my audio editing in Audacity stutter, like the playback stutters. And you're wondering, is this an artifact of the overloaded CPU or what? And it's always an artifact of the overloaded CPU. It's not a problem with the audio usually. So at this point, it's gone from I need to plan my day to I'm going to go upstairs and make myself a cup of coffee and then come back down and it'll be done. And you kind of can't beat that. That's awesome. But it got 95% through and my PC shuts off and reboots. It's like, what? That's weird. I've seen that happen before, generally when I'm smashing it with Stable Diffusion and having it generate really big images, right? So that's got something in common, right? I'm Stable Diffusion, AI on the video card, using the video card really hard. This is, and for a long period of time, right? It wouldn't happen regularly. It would happen really intermittently. Well, now I've nailed it down to a repeatable test case, right? I try and subtitle this video and it screws up at about 95% and reboots the machine. So I do a little bit of searching around and there's other people reporting those issues in the RockM repository. And the working theory, which I'm inclined to buy into, is that there's a problem when you push video cards that hard for that long that doesn't show up with video games, because video games tend to have a more peaky workload where AI just slams it for a long period of time. Okay, now at this point, I should probably mention the fact that I chose the career that I did, which is software engineering and sort of anything computers. I love this stuff, like to the point that I'm a junkie. And these types of toothy problems were always the ones that I liked. And I will chase them to the exclusion of all else. And you really need to be careful with that, because like any other junkie, you don't eat, you don't sleep, you can't sleep. You wake up in the middle of the night thinking about it. Your relationships with the people in your life suffer because your kid wants to play a game and you say, look, I'm sorry, but this was not pre-scheduled. We didn't plan anything, and I thought I had a free afternoon, and all I want to do is work on this. So if you can get everybody who wants to play a game, I'll stop and do it. But if you're just looking to kill time, go build Lego or something like that. And that is a real harsh thing to say to a kid on a Saturday afternoon. But I suppose on the other time, the kids need to learn to entertain themselves. Point being, he went up and helped his mom and brother make pierogi, or they watched a show or something like that. But that is something that you need to watch out for, because you will go down this rabbit hole, and it in the moment feels really joyous, but it can harm the relationships that you have with the people that you care about. So you need to be cautious of that, which is why I try and limit myself to doing it after they go to bed, because then they don't need anything from me. But the problem with that is you end up staying up too late and not getting enough sleep, and then you're grumpy with them the next morning, and then you also need to make sure that you are sharp and awake enough to do all the driving of bringing them to places that you need to do. And it's a little easier, different. I'm not really sure what the difference is when it's a job, but only a little, because if it's a good job, it'll still be keeping you up at night and you'll still be thinking about the problems. And it's the way to maybe describe it is in the A-Team, they would always talk about Hannibal being on the jazz. And that's what it is. It's you're on the jazz. And when you're done, you lean back and you say, oh, I love it when a plan comes together, which I got to on Saturday, at least for the most part, and I'll get into it. Anyway, AMD GPUs rebooting under workloads. So I dug into this, and this is a Radeon 6900 XT, which has a boost clock rate of 2250 megahertz. Okay. This board is factory overclocked and is supposed to peak at 2475 megahertz. In order to overclock, or in this case, underclock an AMD GPU on Linux, you need to add a feature flag mask to your grub configuration so that it passes it to the kernel when the kernel boots. And again, I'll have the documentation for this in the show notes if you're interested in chasing it down. Once you do that, it creates some additional files in the file system that you can read and write that will give you more visibility into what is going on. What I found was the core clock was set to minimum 500 megahertz in power state 0, fine. And in power state 1, which is the maximum power state, was set to be limited to 2594 megahertz, which is 119 megahertz more than what the board manufacturer says is the overclocked speed. So I don't know where the GPU driver got that number from. This could be that it's reading it out of the card's BIOS, and the card's BIOS is bonkers. It could be that it's reading it from some table inside the kernel device driver, and that's bonkers. I don't know. But I set it to low, right? Without unlocking the feature flag, you can just set it to the lowest power state, and it will run the clocks at the lowest clock rate. And I ran the subtitle test, and it took like 45 minutes, which is still way better than 2 hours, and didn't reboot. Okay, so now we're on to something here. Fast forward to now I set the overclock feature on lock. Yay. Now I can look at this stuff. Yay. And I see that it's going over by 119 megahertz. Okay, so now what do I do? Well, it makes the most sense, I think, to set it to something below the factory boost clock rate, which was about 2.2 gigahertz. So I set it to 2 gigahertz, ran it again. I don't know, it took 20 minutes to subtitle that thing. Didn't reboot. Okay. Let's go to 2.2 gigahertz, which is what the factory boost rate is. I think it was 2250. So I set it to 2250. So non-overclocked factory boost clock is the maximum that it can do. Took 10 minutes, didn't reboot. Okay. Let's go to 2475, which is what the board manufacturer says it can do. Now we're down to 5 minutes and it's fine. Didn't reboot. And I've actually rerun it several times because I started tweaking the different settings to try and get, different line lengths and more accuracy and more time accuracy and all that. I think I've run that same test, set with the boost clock set to 2475 megahertz half dozen times, and the system hasn't rebooted. So that's the issue. And I don't know if anyone in the Linux kernel community is aware of this or not. I should probably dig into it and maybe report it. But the boost clock states for a lot of these AMD cards, I can't say a lot because I'm seeing people talking about it on the internet, and it bit me. So I have a confirmation bias because I went looking for it. For all I know, this is not really affecting that many people because it only is the people with, I don't know, ASRock cards or Asus cards or some small subset, and other board manufacturers don't do that. It also could be that this is somewhat intentional in that all the driver does is read it from the card, and the card is saying, well, our boost clock is 2475, but we're actually going to allow it to go a little bit higher to eke out that extra little bit of performance in the benchmarks, and maybe nobody will notice because they won't drive it that hard for that long and it won't reboot. And then you schedule an AI workload on it and it reboots predictably all the time. I don't know. We'll see. Point is, I played around with a few other different models. The large V3 turbo model sacrifices accuracy for speed, and going back to the original 8-minute and 48-second video, it actually did it in 29.1 seconds, down from 44.5. I don't think a 1/3 reduction in time taken when we're talking about, like, realistically on the 2-hour video, right? I could cut it down from 4.5 minutes to 3 minutes. I would lose so much more time in having to fix its mistakes. And I did check, right? I compared the two output files from large V3 and large V3 turbo. It's things like Assetto Corsa was capitalized in large V3 and it wasn't in large V3 turbo. So I would have to go in and fix the names. I go through all of the subtitles and I hand edit them and I check them for content and length and I make sure everything's done correctly and punctuated correctly. I watch the video at 1.5 times speed. So I'm going to have to spend almost the full runtime of the video working on it. But that said, every time I have to pause it, it adds 15 seconds, right? Because I've got to pause it, make a couple of changes, then hit play again. And every time I do that, it adds 15 seconds and that time adds up. And what I'm trying to do is minimize workload while maintaining quality to get videos out faster. If that makes any sense. So I think large V3 is the sweet spot. I played around with both large V2 and large V3. They are almost exactly the same size, and I'm not sure which one's more accurate. If you look at the accuracy graphs that I found online, they're really, really close. There's a huge difference. Turbo is way faster but less accurate, but it's almost as accurate as large V3, right? But it's enough that I'm not willing to make that trade-off. Last thing, audio generation. This one was a failure. I worked at it for 2 days and finally gave up. So I had been using Music GPT, which uses Microsoft's ONX Runtime. We'll call it ONNX Runtime. I assume that's what they're going with. ONNX Runtime has notes from AMD where you can recompile it for ROCm. I was able to compile ONNX Runtime 1.20.1, which is what Music GPT expects, and get that all installed and hooked up and working, in that it started, but then it would segfault. And the segfault looks to be in the built ONNX Runtime library. And I didn't feel like debugging more Microsoft stuff. I did too much of that when I was a NT kernel developer. Found some bugs in Motorola stuff too. That was fun. Anyway, point being, I was thinking, oh, what if I were to just use a new version? It is not built with ROCm support by default in any of the official releases. And I have to assume that there's a reason for that. And the reason for that is probably somewhere in the realm of it's still kind of experimental and we're not really sure of it and we don't want to ship something that's fragile, which I appreciate. So I tried just building the most recent version, and that wouldn't even build because there's some feature in my compiler that I don't have, and so, but it thinks I do or something, and I didn't really want to chase it. Basically, there's one feature where it checks to see if your compiler supports interference warnings, and mine does, but then when it goes to build it, it complains because you've specified to warn if there's interference, and I don't know what that is. So it's either grabbing the wrong compiler or something. But given that now I've gone one version away from what the Music GPT front end expects, I'm going to start looking for other options. And so I haven't finished that search yet, but I have narrowed it down to the vanilla music gen library I could write a Python front end for and just use. And just to be clear, I wanted to do a quick test. Generating 30 seconds of audio with Music GPT, which uses the music gen backend, but in an unoptimized fashion, was 7.5 minutes. Now, I mentioned this to my friend Ian, among other people, and he said, why are you using some rando thing? Just run it under transformers. Hugging Face's Transformers has broad support for many things, including Music Gen, and is hardware accelerated. So I grabbed Music Gen via Transformers and wrote a quick, not user-friendly 3-line based on the example Python script and ran it, and it generated the same 30 seconds of audio in, I mean, it's not exactly the same, but it was the same prompt, and it was 30 seconds in 2.5 minutes. Which is not super quick, but we're still at, I set up a batch of jobs, generate 10 clips of audio with the same prompt, and I'll pick the ones that I like and delete the ones that I don't. That's kind of the AI generated music workflow that I have for this channel right now. And if I do that, I just walk away. I let it do it overnight or whatever. And I come back half an hour later and it's got output. Okay, well, this will be 15 minutes later, but it'll still be, some output. And it'll just be done sooner. So then I started looking at other options, and I came across Audiocraft, which is a front end for several different models, library layer abstraction, including Music Gen, which generates music, and Audio Gen, which will generate other things like interesting sound effects and stuff that I haven't really scratched the surface with. Okay, so I'm going to use Audiocraft, and I might write a front end for Audiocraft. But I went looking, and I found Audiocraft WebUI, which I have not yet tried at the time of recording, but I'm going to do it at some point. And that one is interesting in that it allows a lot more tuning, a lot of different models, and is hardware accelerated. And I mean, if you install the hardware accelerated PyTorch installation, if you install the hardware accelerated PyTorch packages, you'll get hardware acceleration for effectively zero additional work. And it also supports batching, which I like. So I can say, generate me 10 of these, go, and it'll do that. And I can also do 3 like this, and 1 like this, and another one like that. And then I can go back and see which ones sound good, click those, and have it regenerate more based on the same prompt. And it supports even longer audio lengths. And I don't know what the limit is on that one, but one of the things that I found was a problem with Music Gen was it's limited to 30 seconds of audio, 29 seconds of audio. And I don't know why, but various people seem to have been able to work around it. And so I'm going to kick the tires on that one and see where that goes. Because what I would end up doing is if I had a bunch of high-speed footage, me painting or stuff being printed, I'd pull in a 30-second clip, then fade it out in another 30-second clip. And it would be in the same style, and it would just give your ears something to listen to while your eyes are watching the high-speed video. In this case, what I'll end up doing is just generating larger loops. If I can generate a 5-minute loop, that's fine. Another thing I did in a completely different approach, radically opposite direction, is I pulled out this guy. This is a Yamaha Portasound 400 from the 80s. It was my brother-in-law's, and he gave it to my wife when he moved out to California, and I don't know if she used it or not, but it's basically been sitting in a closet ever since, until my son needed it for a live musical performance for his Odyssey of the Mind. So we pulled it out. It takes C batteries. I had a pile of lithium-ion C batteries that we use in the battery-powered Christmas wreaths, and they're lithium-ion both for weight and also runtime. And Miles and I started messing with this in the context of Odyssey of the Mind, and it's actually got a fairly rudimentary synthesizer. And I'll throw a couple of loops in here so people can listen to them. So then the problem is, how do you get a good clean output on it? It has a line out, which you plug in with an RCA cable, right? Not a problem. But my laptop doesn't have an RCA in. Oh, it does have headphones too, but the headphone out on this to the microphone in, it's either the amplification level is wrong or it's just not very good on my laptop. And I don't know why that is, but I've always had a problem with that input. The first video I did, there was a lot of background hiss, and I was trying to get as clean of a signal as possible. And in consulting with some friends of mine, they basically said, you want your analog to digital converter as far away from messy noise like CPUs and things like that, and as close to your analog source as possible. And you want it in an electrically clean environment that's not going to pick up radiated emissions. And that's how you get really clean audio. So this is RCA out, which then goes to an 1/8 inch jack in. This is the other end of the same cable. And this is a very inexpensive, I think it was like $10, microphone in and headphone out. And the other end is USB. So the ADC is in here, right? So literally you just plug this up like this, and I was getting nice, clean audio for $15. And it's also very portable, so I can do it anywhere. And I also have, this is a DAC that will give me headphone out. So if I needed a cleaner output, I can do it. I don't know how amplified this is. I haven't ever used it for that. I only used it on the audio input side. And so I've been pretty happy with the output. And I'm interested to know what people think. By the time I've edited this, you've already heard it. So let me know in the comments what you think of it, both in terms of how clean the signal sounds and also whether or not you like the style versus the AI that I've used in other videos. All right, so that is Computer Stories with Matt for today. Since I mentioned it, the recommendation for this week is The A-Team. This is a 1980s TV show, 5 seasons. My mom got me this box set for Christmas a while back. Thank you, Mom. And it was one of my favorite shows growing up. The introduction kind of explains it all. Basically, it's this team of 4 people who are Vietnam veterans who were framed for a crime that they didn't commit. They essentially are what we would call these days special forces, and they are clever, inventive individuals who engage in a sort of Robin Hood-esque redemption arc, if that makes any sense. They want to clear their names, but that's hard to gather the evidence to do that. So the long plot arc is they want to clear their names. And it takes a twist, I think, around season 3, where they end up working for a guy who's like a CIA guy, and he protects them in exchange for them doing jobs for him of the clandestine nature. But the earlier seasons, they are making money helping people as soldiers of fortune. So these are people who are being victimized by gangs or corporate interests who want to come in and take over their farm, or any of those small person fighting big person who needs some help types of tropes. And there always ends up being a construction aspect of it, in that they have to build something in order to help the townspeople defend themselves from the bandits or whatever it is. And the theme music comes up, and Mr. T is always there welding and doing all that. And then, so there's 4 main characters, okay? There's George Peppard, who I believe was a Marine and plays Colonel Hannibal Smith, who is the commander. There's Dwight Schultz, who also went on to play Lieutenant Barclay on Star Trek The Next Generation, and he plays Howlin' Mad Murdoch, who is the pilot. There's Templeton Peck, who is played by 2 different actors, one of whom was actually Starbuck on the original Battlestar Galactica, and he plays Peck for most of the seasons, but the first season was some other guy who I don't remember. And he's Face Man. He is the guy that smooth talks and gets concessions or whatnot. A lot of cases they pretend to be film producers, and you will get apparently a lot of help from local government officials if you have a script and are going to make a movie, and they would love for you to shoot the movie in their town, so we will help get you the equipment and all of that you need. And then there's B.A. Baracus, who's played by Mr. T and is the mechanical genius and also muscle. He does mechanical things and electrical things. He's essentially the techno whiz and doesn't like to fly. And that is a recurring gag throughout the whole thing is, why are we at this airfield, Hannibal? I don't want to fly. I don't want to fly with that crazy fool. And, Murdoch is coming in some beat up aircraft, and they have to pretend that, there's mosquitoes and, I got it, BA, I smacked the mosquito. And then they get him with a hypodermic needle of some sedative, and he falls asleep right on the horn inevitably, and he goes, and it's a gag. This was primetime TV, so one of the things to realize is that it's an action series, but nobody ever gets killed. They're very careful. They shoot a lot of guns, and nobody ever dies, right? There occasionally might be a murder, but it's always one of those things where it happens off screen and they're investigating the murder. All of the gunplay, it's always hitting walls or the ground, and there'll be a car chase and the car will flip, but you'll always have a shot of the guys getting out of the car so that they didn't die. And sometimes there'll even be a voiceover of saying, "Oh, are you okay, Harry?" "Yeah, I'm all right, George." And they get out and, walk away. There'll be huge explosions, and the worst that'll happen is somebody will end up, with a bandage around them or a gash on their head or something like that. But it's very clear that there's no fatalities because it's prime time 6 o'clock, 7 o'clock TV in the 80s, and you can't show people getting killed. That's not how this works. So in the end, that means it's fairly suitable for all ages, as long as you don't have a problem with violence that doesn't result in serious injury, and which kind of sounds funny to say. Let's put it that way. So put another way, it's like John Wick as far as gunplay. Okay, it's more rudimentary than John Wick. Keanu Reeves did a lot of training for those movies, and his gun handling and reloads are super slick and superb. But point being, there's a lot of gunplay, and nobody ever gets hurt. So it's John Wick without the body count? I don't know. That's it for this episode. I hope you enjoyed my stories. I hope maybe you learned something. Thank you all for watching, and as always, stay nerdy.